Hello guys, welcome to Learn Easy. Today I'm gonna show you how to do suspension analysis using Adams car. So there are two modes to Adams car. One of them being the standard mode, and the other one being the template mode. Using the template mode, we can create the geometries, whereas using the standard mode we can change the basic structure of the geometries. To do suspension analysis today we will be using the inbuilt templates and modify those templates according to our need. So the standard interface, okay, and here we go. Go to file, new. First we have to create a subsystem. Now this subsystem is like a part that is used in other CAD softwares. Opening the subsystem, we have to give it a name. Suppose let's name it trial. Now we have to define the minor role of this subsystem, that is what is the main location of that subsystem, whether it is at front, rear, or is it a trailer section. We are going to model the front suspension, so we select front. Now we have to select the template name, that is a template on the basis of which we are going to make this. Before that, we have to remember to first select a working directory. Go to select directory and let's make a new folder. Not here. In the desktop. Okay, a new folder. Let's name it Adams for the time being and select the folder. Okay, so that has become the working directory. Now to select the template name, go to search. Now there are three locations, one of them being the FSA templates which I downloaded over the net, the shared templates, and the private templates. Actually the shared templates and private templates are two folders within the default location of Adams itself. We would be using the shared one since shared ones are not modified, and so we click there and here comes. So these are the templates that are present in the shared database. You see, this is the location of the shared database. Okay, now today we are going to use a simple double wishbone suspension. So click double wishbone and OK, and we get a suspension. Now there are different commands to manipulate this model in the 3D space. We can always view these commands by right clicking. See, for front view, a capital F, or that should be implemented as Shift plus F. Similarly, all these views can be used, and to select it we can right click anywhere and then select. Similarly, if we want to have a solid model instead of a wireframe one, click shaded and here comes. To rotate, just click R, or rather press R on the keyboard and you can do so. But remember, once you leave the mouse, the command is gone, so you have to rotate it again, then again press R and rotate it. These are the few points that you should remember while manipulating the model. So front view, Shift plus F. Okay, now let me go to isometric view, Shift plus I. Now you see, we got the basic structure of the double wishbone suspension, and with these being the upper A-arm, the lower A-arm, the strut, and even the drive shaft. Also there is the tie rod. Now you must know that the geometry of the suspension is very much no. Okay. The geometry of the suspension is very much dependent on the steering system. So what we need to do is create an assembly of the suspension. The assembly being, go to new and go to suspension assembly. This assembly would actually give my suspension system wheels to provide tow, camber and such, and also testing rig which we need to simulate. So go to assembly name and let's write trial assembly. For suspension system, right click, search the subsystems. You see we would get many subsystems. You see the extension sub. These are not templates anymore but subsystems. We would choose the front steering MDI. Click. Now, oh, I'm sorry. Now see, there is one interesting point. A suspension subsystem was asked, and I by mistake gave a steering subsystem. Now these things can happen. So what to do then? Just right click, go to text, clear. That's done. Now the suspension subsystem is already loaded. We don't want to load it once more. So what we do is just click here and the loaded subsystem would be shown. Similarly, go to steering subsystem, click it, I will do it. Okay. You see the test rig is by default present, and we go to OK. So here we get the whole front suspension setup. Now what we need to do here is, for different geometries of the suspension behaves differently. So we need to set up our required geometry, and that we can do using the adjust hardpoint. All the parts, you see, these points, all of them are actually based on hard points. That is, when they were made in the template builder, points were added, just like we add points in a CAD system. Points were added and elements were drawn through those points. So since it's a parametric software, we can actually change the location of those points and the material would be adjusted automatically. So let's see how is it is done. Fit all and isometric again. I would okay. So let's go to adjust hardpoint. Now there are a couple of methods to adjust a hardpoint. One of them being the modify, the other being the table. The table is by far the most easy to use. So we go to table. Now here comes a thing we should keep in mind, that we should try as far as possible to remember the names of the hard points. You see, the HPL drive shaft INR refers to this hard point. The LCA front, that is the lower control arm, also these three letters indicate hard point left, lower control arm and front. So it would mean this is the lower control arm, since the car is facing this way, so this would be the front. Let's see, we change the location of X, Y, let's make Y as minus 300. Okay, let's see how does it change. See, the front has changed to Y. Similarly the rear, let's do it minus 300 again. The Z, I would like to equal it with the front, so 150. You see, one more thing is that there can be no suspension where the left part and the right part are not symmetrical. So as we change the left part, the right part gets automatically adjusted by itself. Similarly, the upper one, we can find, since the lower control arm, it should be something like upper control arm or UCA. You see it's here. So now here comes, suppose we want to make a double parallel wishbone. So to make such, we the distance between these two and distance between these two should be same. So let's go and verify the front and the rear. Y is given as 300 minus 300, X is minus 200, 200. So I would set it the same way, 200, 200. Mind you, this is just a demonstration of the capabilities. You see. Okay, and let's go to front view. Then this is the upper control arm outer and this is the upper control arm outer. Similarly, we can suppose if I want this to be perfectly horizontal, 530. Since this is horizontal and for double parallel it is has a X and Y of 40 and minus 675. Let's make it 0. Let's make it minus 700. Easier to remember here. There's nothing technical going on, just demonstration. It's 0 and let be minus 700. So you see it has become, no, not yet, because 150, 150 should be 152. Alright, so now it's double parallel. So in this way we can change the suspension geometry. Now let me go to one more thing, is how do we change the geometry of the steering system. You see, we can select whether we have to change the system of whether to change the hard parts of the subsystem or of the assembly. A subsystem is selected, so we can click the down arrow and choose the steering subsystem instead, and here we go. Let's see, pinion pivot for a centered column. The pinion pivot, let's see if it's 0. I'm sorry, it should be 0 here. Oh, 200. Okay, so 0. Similarly, this point should be 0 more or less. Everything should be 0, I guess, and apply. So the rack hose mount, tie rod inner, they should be something other than 0. Minus 300. Then minus 300. Okay, so in this way we can change the subsystems. You should keep in mind that these 2 points should always coincide. So to actually change it, we have to go back and forth between the steering subsystem and the steering subsystem. The tie rod, this is the outer tie rod. I'm sorry, this is the inner tie rod point, and this is the outer tie rod point. So the inner tie rod inner, it is situated at 200 minus 400, 300. So tie rod here 200. What was that? 200 minus 400, 300. So 200 minus 400, 300. And so similarly I can change it to minus 400, and we get them joint like we wanted. Okay. So this is basically the way you can create suspension systems. Mind you, you can change various parts of the geometry. For example, changing the location of the mounts of the A-arm, changing the shaft, changing the direction the steering is facing, because the steering is made in such a way such that it would always face a direction which is perpendicular to this rod. So if I go and change, I guess this one to any value, or say this, the steering system would automatically direct itself. Okay, so it was, I guess, 720 or something like that. Okay, you see. Okay, now let's come to the important part, the simulation itself. Now let's see. To start simulation, go to simulate, suspension analysis. Before we set up any simulation, first go to set suspension parameters and let's look a bit at these properties. This is the unloaded radius of the tire. To find out what units we are using, just go to settings and units, and you'll get the units you are using. You can even change the units if you want. Okay, so it's 300 millimeter, the tire radius. You can always change them to get a tire of your choice. Is the tire stiffness. You can even set up a property file. These are the many tire properties. You can go through these files. You can open these files in Notepad and see what are the different properties these files have. Okay, we are going to use a user-defined, a rigid wheel. Then we can set up the sprung mass, total mass, the CG height and the wheelbase, the brake ratio. If there is no braking in the rear wheel, it should be 100. If there is no braking in the front wheel, it should be 0, because percentage front, and like that. Similarly, the drive ratio. For rear wheel drive, it should be 0, and for front wheel drive, it should be 100%. For four wheel drive having a similar equal transfer of power, it should be 50, and so on. Let's set up, simulate. First we'll go to parallel wheel travel. This is the name of the analysis. Let's say trial 1. Now let's come to the number of steps. Number of steps is the total divisions in which the animation would be done. The greater the number of steps, the smoother the animation will be, but the more time taking the simulation would be. 30 is a good number to start off your simulation. Then we come to bump travel. With respect to the wheel center, bump travel is the amount the wheel will travel vertically upwards during a bump, and it's given in millimeters because in units it was in millimeters. Let's see about a 4-inch bump and rebound. A 4-inch means 100 millimeters about, so 100, and in rebound be careful to set it as -100, because a positive value would always denote a vertically upward direction. So rebound would always be in the lower direction, so it would be -100. Okay, so let's start. You would be good enough to go through the messages the window is showing, because there can be times that errors can be there. If there is error at the end, it would be written that there are errors and the simulation couldn't complete. So it would be good of you if you could roll back to the place where the error is mentioned, and it can very well be helpful in debugging the simulation. But for me, the analysis was complete, so let's close it. Now we want to view the analysis, so go to review, animation controls. The analysis is pre-selected because that is the only analysis present, and to view it, let's go to play. Thus we can see how you can note that during the travel there is a change in the toe of the wheel, a very minute change, but a change nevertheless. Similarly, I guess there would be a change in camber. No, well, a little bit I can guess, but these details are very difficult to find in animation controls. Animation controls just is a very good representation of how the suspension would travel. It's a very good visual representation, but generally we need more than that, and for that we should go to review and post-processing window. It is in this place where we can draw graphs of the total simulation. Okay, so there are a couple of ways by which we can draw. The easiest way is to go to plot, create plots, and open a plot configuration file. The suspension parallel travel gives the most number of results, so click here and OK. So let's see the camber, how the camber is changing. Here it is. This is the wheel travel in millimeters and the camber in degrees. You can find out the intermediate values by clicking here and just go through it, and the values will be written here, including everything. Similarly, we can get a caster angle. Then there is toe. Here it is. Wheel rate, and so on. There is also another way we can do it, that is using this place. Go to test rig, double click, and there are few more here. Go to inclination angle, then select left and right by pressing Ctrl, and the independent axis, that is this axis, you have to select whether it would be the time or any other kind of data. If we select data, they have to select what kind of data it is. Let's try to find test rig. Wheel travel. Okay, and add curves. So you see here, for the wheel travel we can get what is the inclination angle. Now we can create some more items like spec lines. Let's say y value is y value 85, x value 0, so 8520, and so on. We can even, if we feel that this box is hindering our vision of the lines, we can even change the location of this blue box, and so on. We can select these lines and change the representation of the lines itself. So there are a couple of ways which we can freely use this. Then comes the way we can export this to a spreadsheet, report, or file. And so on. We write the file name, set name, and so. So this is basically the way by which we can do suspension analysis. To close it, let's first remove this, shift, select, then control X, and it's done. Go to file, close plot window, and you're back. If you want to change the parameters again, go to Hardpoint, table, and change them. Now there is one more thing. You can actually change the static toe and static camber by going to adjust parameter variable table. So there is the camber angle and the toe angle. Just to show, let me give a value of negative 20 degree, and you see the camber is set. To save, go to file, go to save as, subsystem. Remember to click directory instead of database, because selecting database would save your file in that private folder that I showed you before. So instead of database, go to directory, and the working directory would be selected. This is the subsystem name. I don't want to give any new name, and OK. Don't forget to save the assembly itself. Go to directory, OK. Yes to all. So that's that. To close assembly, that's done. So again, if you want to open our subsystems, go to open, subsystem, right click, search, or browse. And if you have selected the working directory previously, we can get the subsystem there. Click OK, and the subsystem would be loaded again. Similarly, we can also open assemblies. And that's done. So these are basically the way you can easily do suspension analysis. So that's all for today. See you next time.